Hello, welcome back. So in this lesson, we're going to move away from just raw oscillators, and we're going to start talking about synthesizers in Tone.js. They're basically like instruments that we can use to trigger some notes, and they have lots of different parameters we can tweak to affect the sound, the timbre, and just lots of other nuances. We're also going to start talking about musical notation and the idea of working with musical scales. So let's get right into it. So I'm starting here from the sketch we did in the previous examples, and we're going to do a little bit of house cleaning. But first, I'm going to remix this project, and then we're going to get rid of things that we don't need for this example. So I'm just going to delete the oscillators and the LFO. I'm going to keep the waveform object so we can keep seeing what our audio looks like. And then we're going to do a little bit of housekeeping here. So let's put these in, little function dividers, because this code is going to get a little bit longer. We also don't need this anymore, like so. And let's put one here. Let's put one here. And over here. The other thing we're going to do is, I mentioned, we got rid of the OSC, so let's delete that. In the previous example, I mentioned this could have been a function, right? So let's do that just because in case we down the road want to do different things in draw, we're going to take this code and tuck it away in its own function. And we're going to call that function draw waveform. And just in case we end up wanting to draw, multiple waveforms at once in the future, we're going to put a parameter to the function, and I'm going to call it wave, so I don't have to change any of the code I've already written. I'm going to copy this down here into the function, format the code, magical, and then in our draw function, we can say draw waveform now and pass in our global wave object. The other thing we might want to tweak right now, we're not going to use it in this example, but just for the future, is let's add a couple of parameters here. One is going to be called W for width, and let's set a default value of width and height, right, for W and H. And then when we're actually drawing the waveform in our mapping here, we can use these parameters instead of the window width and height. So in the future, if we wanted to set, different dimensions for our our waveform drawing, we could pass in parameters. And if we don't care, we just leave them out, and the default will be the window dimension. Okay, so that's it for the housekeeping. So let's dive into this this next lesson here. So what we're going to do is we're going to create, instead of just a raw oscillator, which is just a continuous waveform, we're going to create a synthesizer object. And we're going to call this variable, let's call it a synth. And then in setup, we are going to say synth equals new tone.synth. And then just like with most sound generating objects in Tone.js, remember we have to chain things together. So our synth is not going to make any sound until we connect it to something. And in this case, we only have the tone.master to connect to, or we can say to destination. Which remember is the same as saying synth.connect tone.master, which is our master audio output. So what a synth does is it allows you to play a note, but it allows you to trigger this sound using what's called an envelope. Now an envelope has an attack component, which is how quickly the sound comes in, and it has a release component, which is the sound fading out. So let's see what that looks like. We're going to go into mousePressed here, and we are going to say synth.trigger attack release. So we're going to trigger both the attack and the release together, and we are going to put in a frequency. So let's go back with let's start with our 220 Hertz frequency. All right. So we can see here, it's playing the sound, right? And when I click, it's giving it an attack, and then there's some release going back down. It doesn't go all the way down, so let's add another parameter here, and that's going to be that's going to set the duration of our note. So right now we didn't give it any duration, so after the initial attack, right, there's a little bit of decay, right, and then the release just remains at some default level. So the duration of our note, there's a few ways we could express it. We could express it in seconds. If you just put a number, I'm going to put 1, see what happens. Right? So now we have the attack, and then the release, right, takes 1 second. Or we could also express it, and that's often how we're going to be working with these timings here. We can express it in terms of note fractions. So for example, 1 note, this is like an entire beat of our tempo. There's a tempo which is by default, I think, 120 beats per minute that is happening behind the scenes with Tone.js. And then we can set durations that are basically dividers of this tempo. So 1 note is is an entire beat, right? 4n would be a quarter note. And these will be all relative to this global object called the transport, which we're going to talk about in a second. So when we trigger a synth, we can set the note duration, like so here. And instead of thinking of it in terms of seconds, it's helpful to think of it in terms of, quarters of a note, eighths, like fractions of a note. This way, down the road, if we change the tempo of our sketch, these note durations are going to scale accordingly. If we want an even shorter note, I'm going to put 8 here. So the bigger the division, right, the shorter the note. And you can go, you can go as high as like 30-second notes, right? These are very short little bleeps here. So let's go back to 8. So far, right, when we're triggering our synth, we have the frequency, right? Then we have the note duration. And then the last thing we can put in is a time parameter. Now, by default, it assumes you want the note to play right now, right? So it just plays. We can also put a time parameter here, which will be a number of seconds we want the note to play in the future. So for example, we could set a 1 here. Actually, a +1, that would be 1 second from now. Now when I click, there's a 1 second delay. So what that means is with Tone.js, we can schedule notes to play, and we can pass that as the last parameter. Now, usually we're not going to manually schedule notes like this. We are going to let Tone.js give us some time parameters that we're going to pass in so that we can have, for example, a loop running, and we can have a note getting triggered on the beat consistently without worrying about our draw code affecting the synchronization of our audio program. So the last parameter here is going to be time, and the default is basically just right now, whatever the current time is. So we're going to leave it out here for now. Okay. So let's talk a little bit about the transport. So in addition to the master, so the master is like the audio volume. The transport is basically your master time object. If you've ever worked with a DAW or a digital audio workstation, the transport is where you have your time and your start and stop button to basically play your track. So there's a similar thing going on here with Tone.js. So the object here is called Tone.Transport. And it has a start, a stop, a pause. So when we press the mouse here, we're going to start the transport. And then what that allows us to do is then we can also now start to create, there's a whole collection of objects in Tone.js that allow us to create these rhythmic sequences. So let's take a look at the API here for a second. So let's scroll down here. In the event section down here, we see we have loops, parts, patterns, sequences. We're going to explore some of these in coming weeks. For today, we're going to play around with the loop. So the loop is a simple idea. It allows you to define a callback or a function that's going to get called at a specific time interval. Okay? And then we can schedule it. Right? It's going to get started and stopped alongside the transport. So if you stop the transport, your loop will stop and so forth. So let's create a loop in our sketch that's going to allow us to ping this note here at a regular interval. So right below my synth object here, I'm going to create a variable. I'm going to call it loop. That's going to be our loop object. And then in setup, I'm going to say new tone.transport. loop. Now the parameters to loop here are going to be two things. There's going to be a function that we're going to pass, that we're going to call every time the loop triggers. And we haven't defined that yet, so let's go and create one right here. So the function is, let's call it loop step. Okay? And the parameter to that function is going to be one value called time, and we'll explain why in a second. So loop here, we're going to say loop step. And then the second parameter is going to be the frequency. So here, this is where the time divisions become useful. For example, if we wanted something to happen every quarter note, right? We could say call loop step, right? Every quarter note. We're going to start the loop. And then inside loop step, we are going to put our code that is playing this note. So now this code is being triggered automatically by the loop here. Now you may notice the timing is kind of off, okay? And that's because audio timing is very precise, right? So when we do these callbacks, there's always little fluctuation in time when the code actually runs. There's a lot going on in the browser and in JavaScript. So the way that that Tone works with this, this is why it gives you a time parameter here. And it's going to allow us, I'm going to pause this, it's going to allow us to schedule our notes based on the time parameter that we receive. So whenever loop step repeats, right, we're given a time value that we can use to sync our notes with the beat. So if loop step gets called not exactly at the right time, what it's going to do is going to calculate, here's exactly in the future what time that note should play in order to be perfectly in sync. And all of this gets taken care of by the transport object. So this is why this time parameter is useful here. So whenever we're going to have sequences and various patterns, we're going to have this concept here where we're going to get provided a time variable by Tone.js, and we're going to pass it whenever we try to play some notes to make sure things happen in time. So let's listen to the difference here. So now this is a lot more regular, okay? And we can change the frequency here. We could make these 16th notes, right? We can make it happen really, really fast. We can make it 8 notes, right? And then we can also, we have two things we can play with, right? We have the duration of our notes. We could decide to make those slower, right? And then we have the duration of our loop, or the frequency of our loop. So for example, we can make these quarter notes that are short, or we can make them quarter notes that take up a lot more of the time. So we can change with the note duration and also the loop frequency. So let's go back to some frequent notes here. That's a little bit too much. Let's go with 8 notes. All right. So let's talk about maybe randomizing this note frequency. So we're going to start here with like a very naive approach to this, and we're just going to create a random number for our note. Let's say we're going to go from 110 to 820 and 880, right? Go from a low A to a high A. We'll talk about those note names in a second. And we're going to just plug that into our synth trigger. And this is going to sound terrible, but let's do it anyways. All right, so we're able to generate, different random notes now. But the problem is that this is like really dissonant. If we make it happen really fast, we can make little computer bleepy thinking noises, which may be what we want. But as far as creating sort of, interesting generative audio, this is pretty limiting because all we're working from here is just these raw frequencies. So it's going to be helpful moving forward to start thinking about our sounds as fitting within a certain musical scale. Okay? So what does that mean? Well, in addition to being able to pass in just frequencies as the parameters to our synth here, we can also pass in note names. For example, if I wanted to play a C4, I could put in a string here that's going to say C4. And let's reduce the time here, slow down our loop. even more. Okay. So we have a few ways we can express notes. We can express them through just raw frequencies, or we can also use these note names. Now these notes, like C4, this comes from the MIDI standard. And let's see what that looks like on a piano. So C4 is right here, right? You can see this is the same note as my sketch. We're in tune. So when we're talking about notes, right, we have a note name. So this is C, and then with the number represents the octave, right? So this is a middle C, which is somewhere in the middle of a piano. A C3 is a C 1 octave lower, right? A C5 is 1 octave higher, and so forth. Right? So if we change that number, we get different octaves. Cool. Now, these are all the notes, right, on the piano. Let's talk about scales here for a second. Now, the easiest of all the scales is the major scale. The major scale basically starts with a C, right? And then it goes up by one note, one white note, all the way to the next C on the keys. So a major scale goes like this. It goes C, E, and then we can go back to the octave, right? So you might recognize this if you've done a little bit of music before. We're not going to go dive in super deep into theory in this series of lessons. This is beyond the scope. We're going to start with the major scale here because it's very easy to wrap our heads around. It's just all the white keys, right, starting from C. And then down the road, if we want to explore different scales, we're going to use, this is where the library Tonal.js is going to come in. Tonal knows about all the scales that exist, and it's going to generate those for us. So we don't have to know anything about how to construct these scales. So for now, let's create the major scale here inside our code. Oops. So we're going to start with C4, and then we're going to make our way up to B. Okay, so, oops. All right. Now, this is typical of most scales, right? We're going to have 7 notes in it. There's different scales that have fewer notes, like the pentatonic scales that has only 5 notes and so forth. We'll explore different ones at the end of this lesson. So our scale is simply going to be an array of notes. So we're going to call this scale. Yeah? And we saw if we want to have a major scale, we're going to start with C. We can start on any octave. We're going to start on the 4 here. So we're going to go C4. Then we're going to go D4, E4, oh, forgot the F, and B4. So that gives us all the notes of a C major scale. Now here, instead of randomly generating a frequency in loopstep, we could pick a random note, and we can do this using the random function. Let's make it go a little faster. All right. So this still doesn't sound very good, of course, but at least we're no longer just generating completely random frequencies. Now we're keeping things constrained within a certain musical context. And in this case, we're playing within the C major scale. Now, where do we go from here? Well, a few things we can talk about. So here I've manually constructed this scale array, right? Just by putting in all the different notes that I want. This requires a little bit of knowledge of music theory in order to do this. Now, luckily for us, the major scale is pretty easy because it's all the white notes, right? Starting from C. There's the 7 white notes starting from C happen to form the major scale. Fun fact, if you want to make also a minor scale, you can start from A, and then you can move up on all the white notes. That's a major scale. Sorry, that's a minor scale. Depending on where you start, you're going to get different tonalities to your scale. Now, if we want to go a little bit beyond just the C major scale, or if we want to, we maybe want to have a D major scale. Now, the D major scale is not going to work because we have some black keys, some sharp keys here. It's not just going to be only white keys. So we can let Tonal.js help us with that a little bit. So if we wanted to get the scale from Tonal.js, right? Remember, Tonal is this another JavaScript library which we've included in these sketches that allows us to deal with ideas around music theory. So musical notes, musical intervals. Intervals are the space between notes. Okay? So for example, right, the space between a C and a C sharp is one semitone. Okay, so a space between a note is called a semitone. The space between a C and a D is two semitones, right? Because we have actually two notes between them, and so forth. So these are called intervals. So Tonal.js knows all about intervals. It also knows about different chords, different scales, and so forth. So let's use that into our sketch to our advantage. So instead of creating the scale like this, we're just going to define a variable. Okay? So let's put a comment here. This is C major. And in setup, we're going to say scale equals tonal. Now here, be careful. Note that it's not Tone.js. We're using a different library called Tonal. They're close in name, but they're not the same thing at all. Tonal as a scale object, and then we can say get, and then we'll say get me the C major scale, and then we'll say notes. And then that works as well. So these are all the same notes as I've inputted into this array here. Now, if we wanted to, we could say give me the C minor scale. So we can play around with this some more at the end of the lesson, talking about what are some of the different types of names of scales we can put in. But this is a very quick way to generate an array of notes using Tonal. The other thing we could play with is we're going to improve our random note generation here a little bit, just for this example. We're not going to get to Mozart level of compositions, but we're going to try to make the sound a little bit more musical. So random, just like in the visual domain, right, has its limits because it's all over the place. So let's see if we could apply, for example, we've learned about Perlin noise in previous lessons. Maybe we can let the Perlin noise drive our note sequence instead of making it purely random, so that at least there's a little bit more of a structure. We're going to get notes that go kind of up and down throughout the scale without madly jumping from one note to another. So let's try to see how we would implement this. So first we're gonna generate a noise value. We're gonna call it n, okay? And we're gonna use the noise function to do this. And the input to it, let's just use frame count, because frame count we know is a number that just moves forward all the time. So it's gonna drive us through the sequence. And then we're gonna divide this by an amount, let's say 0.1 for now, just so that we don't have such huge jumps. Then we're going to use this noise number. We're going to map it to an index into our scale array, right? So that we can, index 0 would be the first note, index 6 would be the last note. So we're going to map the noise. So noise is always going to be between 0 and 1. We're going to map it to a number between 0 and scale.len. Now we have to be a little bit careful when we map into an index. Okay? When we map to get an index here, map is going to return a floating point number, right? So we're going to get in between values. We might get a 0.5 or a 2.378, neither of which are useful as an index. That has to be a whole number. So what we can do is we can say, let's use the floor function. So what floor does, it just says keep the number to the left of the decimal point and then just ditch the rest. Okay, so it's not rounding up or down. Well, floor is rounding down, I guess we can think of it that way. So this is going to give us an integer. So floor rounds down. Okay? We're going to ignore the decimal point, and that allows us to use I as an index into our array of scales. So now we're getting a sequence that's got a little bit more of a structure to it, right? It's still random, but because of the Perlin noise, we're now like moving through the scale a little bit less erratically, right? We just have some up motion and some down motion. Let's increase the number of notes we have in this pattern, so we can see it happening a little bit more. So we can see we're moving forwards and backwards in the sequence. And of course, there are times when we're hitting repeated notes. So let's refine this even a little bit more. So let's think about, we could say maybe we want to get those repeated notes, but at the same time, the sequence really sounds a little bit awkward because it's just a flurry of notes, just a barrage of notes. It's important to have some silence as well, some rest in the sound, so that it's a little bit more interesting to listen to. So what we're going to do is we're going to say only play a note if the note that we generate here is different from the previous note. Okay? So it's going to avoid this this thing where it's constantly hitting the same note sometimes more than once. So in order to do this, we need to know what the previous note was. So we're going to create a variable. We're going to call it previous note, just a global variable here. And after we've played a note, we're going to say previous note equals note. So this way, next time we get into loop step, we're going to be able to look in here and say, what's the note I just played? And now that we have this, now we can say if previous note, right, is not equal to note, then we can play this note, right? Then we can play it. Otherwise, we're just going to do nothing. All right. So this is still, obviously a far cry from some musical masterpiece, but now it's got a few more interesting concepts going for it. First, we've constrained the notes to a musical scale, right? So we only choose notes that are within the scale. And then we've added one other level of refinement, which is we don't play the same note twice. And then finally, we use noise here to move us through that scale. Instead of just a pure random number. There's probably lots of other ways we can think about, moving through that sequence. We could explore, for example, what if we looked at the digits of pi and then use that as our map through the sequence, right? But for this example, we're just going to stick to the noise here, and we're not going to go too much further than this. So obviously, there's still some pretty big limitations here. One is our scale only has one octave in it, so we're only playing 7 possible notes. So that really limits the range of sounds we can create. So we're going to address this in the next lesson by expanding here this range of octaves and playing with this idea of mapping notes to a scale beyond just those basic 7 notes. Some things that we could play with also, we could change, we could use different synths. So this is probably something we could have started with as well when we talked about this Tone.synth, but Tonal.js comes with a bunch of predefined, pre-programmed synthesis algorithms. So Synth is the simplest. It just uses internally a basic oscillator, right? So by default, you saw we have a triangle wave, but we could set different types. We could have a square wave. That would be oscillator.type. All right. We could have a sine wave. So they're going to have obviously completely different sounds. So this is something we can experiment with. There's also just different kinds of synth altogether. So let's have a quick look at the documentation here. In the instrument section, you see there's something called an AM synth, which stands for amplitude modulation, FM synth for frequency modulation, a membrane metal synth, a pluck synth. So there's a few different types of synths. We can just throw in a few here in our code just to experiment with briefly. For example, the membrane synth kind of models, not sure what it models, but it sounds interesting. The metal synth, it's got this really like metallic sound to it. The pluck synth is kind of like a string instrument. And all of these synths have different parameters that can be tweaked. So I encourage you to explore that this week. Spend a little bit of time looking at some of the parameters. So for example, the pluck synth has a resonance parameter we can tweak, a dampening, and they're all a little bit different. So you can get, different styles of plucked notes. Or we can go back also to our basic synth, which is just using the raw, oscillator shapes. So triangle, sine, square, and sawtooth. So another thing that would be interesting to play with, and I'm going to leave that to you as an exercise, is try to see if you could add another voice to this sketch, right? So currently we only have one synth, but we could create a second synth, and then we could let the note for that second synth just be driven by a slightly different noise value, right? In the same way in the visual domain, we had noise creating X and Y coordinates that would sort of move together in sync, but still being driven by noise. We could do this in the audio domain, right? We could have two note sequence playing at the same time using notes from the same scale, but different notes, right? So that sometimes they're going to create chords by playing with each other, and some of them might be silent at different times because they would be using a different noise value. So that could be something to play with to get some practice with Tone.js, adding another synth object as a second voice. And then you can use the same loop sequence, right? The same loop function callback here to trigger that separate voice, just come up with different noise value in order to choose a different note. And then finally, before we wrap up for this example, I want to talk a little bit about the callback function. This is not so much a musical concept, but this is more of a coding concept that we're going to revisit in future lessons. And you're going to run into this when you look at the Tone.js examples. So they have a different way of defining callbacks. So here I've used a function as my callback, right? And it has the time argument. And I know it needs the time argument because that's what the loop documentation tells me. Now, the Tone.js examples like to use anonymous functions in order to define their callbacks instead of named function. So this is a named function. It's like a separate function block that I've written just for this callback here. When you write an anonymous function, there's a different syntax you can use. So functions in JavaScript they're objects just like everything else, which means, here I'm passing a function as a parameter to the loop constructor. I could also declare a function on the fly, so it doesn't need to have a name. It's just going to get created in the parameter itself. So the syntax for doing this looks like this. It's a little bit strange to get used to. So we're going to create parentheses here. So this mimics the parenthesis in our named function, right? So once we break it down, you'll see how things relate. So we're going to have the parameters inside parentheses. Then we're going to use this arrow notation. And then we're going to open and close curly brackets. And then we can write the function inside these curly brackets, right? Directly into the constructor for the loop object. So it's going to help to go on a different line here. We can leave this afterwards. So now we have a space that is basically the same as this space. Okay? So this function doesn't have a name. It just gets created on the fly. And then we could, for example, take the code we have in loop step put it into here. I'm going to auto format here with the sprinkles so that it looks a little bit better, right? So that becomes the code. This becomes our loop callback, right? What happens whenever the loop triggers. And now this named function is redundant. We don't need it anymore. So I'm going to comment it out just to show you that this still works. And because I only had one parameter, when I hit the auto format button, and it actually got rid of the parentheses. You don't need them if you only have one parameter, but if we had two parameters, which once we start creating a sequence object, we're going to have both a time and a note that we want to play. So we're going to leave those parentheses here just as a habit. So this is one way in JavaScript we can declare what's called an anonymous function using the arrow syntax here. And doing it this way also means that the scope of this function is going to be on this loop object itself. So it's like we're declaring a function as part of the loop object, which means we can reference some of the loop object's internal variables. For this example, we don't really need this, but I'm going to point this out again in future weeks when we create node sequences. We're going to make use of that capability of these anonymous functions to be able to define events for Tone.js that are going to be able to use internal variables of an object. If you're totally lost and have no idea what I'm talking about, don't worry about it. I'll refresh your memory when we get to that in a few weeks. So for now, the important thing here to note is that this is the preferred way often. In a lot of the examples in Tone.js, they're going to be declaring their callback functions using that syntax. And it's a little intimidating at first when you first encounter it, because you're like, what does this mean? Time and then the arrow. But really all it does is it mimics, right? It mimics the named function syntax I have over here. The only thing that I get rid of is the name of the function. So I have parameters over here, and then the arrow jumps into this double curly brackets, right? Open and close curly bracket, where I can put in the code for my function. Actually, these two, right? So this is functionally, it's doing the same thing as having a name function. Currently, for our purposes, this just allows us to define the code right in the constructor of tone.loop. We're just going to leave it at that for that lesson. And in future lessons, we're going to talk a little bit more about expanding our note mapping capabilities beyond just having this single octave, and maybe other ways we can look at generating note sequences that are not necessarily Perlin noise. So I'll see you in the next lesson. Hey, not so fast. Hello, it's me from the future. So remember in the previous lesson when I talked about making sure that we wait for user interaction before we initialize or start some of the Tone.js functions? Well, I've realized after the fact that I made a small mistake in this program here. And it was a little bit misleading because if I click to run it, it actually works here, right? The sketch actually starts. But if I try to open it, let's say in this window, where I'm not inside the editor, I'm just going to get greeted by a line here with no sound whatsoever. I suspect that's because when you were editing inside Glitch, the window here is just embedded inside the greater sort of editor, and all the interaction we do when we edit our code counts towards user interaction in that window. So the sound engine is allowed to start, and we may not notice that we did not create our objects in the right spot. Okay. So what that means is we have to be a little bit careful, and we have to make sure we wait until there is some kind of user interaction before initializing our sound objects. Over here, I started my transport in mousePressed, but I did not start my loop sequence, and I went ahead and created some synths and different things. So we have to be a little bit careful with that. Now, some objects you can create ahead of time. Other ones you have to wait until there's interaction. So just to be on the safe side, what I like to do is we're just going to grab everything that has to do with audio with the Tone.js objects. And we're going to cut that, and we're going to put it into a separate function. Let's put it after setup. we're going to call that function initialize audio. And that's going to also include Tone.Transport.start at the end. And then when we press the mouse, we're going to call initialize audio when we know that we're ready to get things going over here. And this way now, if I hit refresh on this page, it's going to load the current version of the code. Now I actually get some notes in this this view of the sketch. Or if I look at it through this view, I'm going to get some notes as well. So my bad. So just be careful with this. And the way to make sure you don't run into that problem is just put all of the code that has to do with Tone.js inside, its own separate function instead of doing things in setup. Think of it as, we wait until there's a mousePressed to do any of the audio setup, and that's usually a pretty sure way to make sure your audio will start correctly. All right, see you next time.